Good everyone, my name is Graphics. Today we want to study an aspect of applied physics, which is also called mechanical engineering science. We'll be studying dynamics. In that dynamics, we're talking about motion. We've already said that motion is a change in the position of the body with respect to time. But there are different ways at which a body can change. A body can change in an horizontal ground, that is moving from one point A to point B, which we call displacement. A body can also change, at least from an altitude, falling from up to down, probably from A to B or from B to A, right? This is at the influence of what? Gravity. Or a body can move on a circular path, on a curved path, right? From A to B. This is called an angular motion. Motion about a point, right? Now that will now take us to three important aspects of motion that we're going to discuss today, which are the linear motion, the motion due to gravity, and the angular motion. We're going to see what unites them together and what separates them. So let's start. This linear motion can also be called translational motion, means motion on a straight line, right? Motion on a straight line can be either horizontal or vertical. Now, in our previous video, we talked about velocity time graph, where we use graphical way in searching for the displacement or looking at the displacement of an object, right? But now I want to look at the analytical way. And trying to solve questions using analytical way, we have three equations of motion. So we're looking at the equation of motion. The first one, we say that V is equals to U plus AT, right? That means if I have a straight line this way, I'm moving from point A to point B, where I start my movement from is called, the velocity where I start my movement from is called U. We'll call it initial velocity. And to point B, that will be my final velocity. So the difference between them with respect to time is what we call our acceleration, A. Is that taken? So we say our acceleration is given as what? V minus U over T. So to know the acceleration of an object, you need to look for the difference in velocity over what? The time taken. So we say acceleration is the rate of change of what? Of velocity with respect to what? To time. And we say our velocity on its own is what? The rate of change of what? Of displacement or distance traveled in a specified direction. So when I move from here to here, you can easily calculate for my velocity as long as time is involved. Now that means I'm making you understand that my V is final velocity, my U is initial velocity, my A is acceleration, and the T here is time. Right? Now this is our first equation. Now the second one is given as what? S equals to what? UT plus what? Half AT squared. Either you call it half AT squared or you call it AT squared over 2. X is times this distance. The distance between here and here, which we know is represented in what? In meters. We already know what U is, know what T is, we know what A is. So the new part I'm introducing here is S. S is given as what? the distance traveled in a specified direction, or you call it the displacement, is in meters too. Acceleration is in what? Meter per second square. Either velocity, final or initial, is given as what? Meter per seconds. Right? And time is in seconds. That's the units. Now, the next one we'll talk about will be v square equals to what? U square plus what? 2as. So this is what we have here. So these are the three of them. In some cases, we do add one to it also. That will also say that my x, and when you have more than one velocity, my s is equals to what? U plus what? V all over what? And 2 multiplied by what? By t. So that is the average distance traveled. Now these are the 3 equations of motion, or will I say 4 of them. Is that taken? Now let's now see. This is when the object is moving on an horizontal ground. Linear on what? A linear ground. Let's take an example and see how it goes. Example 1. Example 1. Example 1. Now we look at this. The question here says that a train slows from, that means this is a present continuous tense. A train slows from 108 km per hour. That means the actual motion, the train was not at rest. It was already moving, right? So it slows from, already is 108 km per hour. So from, when you hear the word from, anything from means initial. So we say that the u here, you write your data out. The u here is giving us 108 km per what? Per hour. Let's move forward. With a uniform retardation of 5 meters per second. Retardation is also given as what? A. But our answer is always negative. Retardation means deceleration, something that is that is reducing in speed. It is decelerating. So we say minus what? 5 meters per second square. This I'm putting minus because of what they say it is what? Retardation. Retardation is negative acceleration. Now we move forward. How long will it take to reach 18 km per hour? Now how long? You start from here, initial 108 km. That is 108 from beginning. How long will it take to reach the final? So that how long means 2. And that is final velocity. And that is giving us 18 km per what? Per hour. Right? So they said how long velocity to reach there, then how long means time, t. We're looking for the time. Right? How long means what is the time being spent to reach the final velocity of this. It's starting from here, how long will it take to reach this? And what is the distance covered? So we're also looking for t. We're also looking for what? For s. So from here, what will actually happen here is we say that velocity is in what? Meter per second. So you need to convert these two guys here to what? Meter per second. So how will you do that? it means that you are going to say 108 times 1000. Why are we using 1000? The word kilo means 1000. All over hour means 3600 seconds, because meter per seconds. So by the time you divide this, you'll be having, that'll give us 30 meter per seconds. Why this? If we do the same thing, meaning 18 multiplied by 1000 all over 3600 to give us what? 5 meter per seconds. Now the question is, which formula am I going to use? First of all, we have this equation of motion here. Let me show you. We have V, all this we have here, but my parameter here, we have UAVTX. Now look, let me show you something. We have UA, this guy doesn't really have, it has X and T, and it's impossible for you to solve an equation that have two unknown. We're looking for what? For S and T. So that's one reason why you cannot use this guy for now, first. Right? Now, if you look at the other one, we're looking for T first. So let's look for T, how long. So I'll come to the first one here. That is this, because I have V, U, A, and T. So I'll say recall. V is equals to U plus AT. So what is the V? The V here is 5. So I'm going to input my 5 to represent my V. Equals to, the U is what? 30. I'll put in my 30. Plus my A is what? -5. I'll input in my 5. The T, it is what we are looking for. So if I rewrite this, if this 30 is coming here to be 5 minus 30, minus times plus give you minus, 5 times 2 give you 5t, right? So there's an equal sign here. Do we have what? Minus what? 5t. Now 5 minus 30 will give you minus 25, equals to minus what? 5t. So if I divide both sides by 5, I'll have minus 25 all over minus 5 is equals to what? T. Minus 5, minus will cancel minus, 5 and 25 will give you 5. So my T will be equals to what? 5 seconds. 5 seconds. Now the next thing is to look for X. So you can easily look for X by using the other equation of motion. So this is for the time. The next one is for X. So calculating, just divide this into 2. So recall, X is equals to what? Ut plus what? At squared over 2. Now what is S? We don't know what S is. So equals to, what is U? We see our U is 30. Then the T calculated for is what? 5. Plus the A is minus 5. The T is 5. But this time the T has a square. So this will now give us 150. 5 times 30, 150. Minus times plus give you minus. 5 square is 25 times 5 will give you what? 125. Right? So from here, 5 times 5, 25 times 5 will give 125. Then 30 times 5 will give you, so my X here will now give me 150 minus, don't forget, divided by what? Divided, everything here divided by what? By 2. So if you divide here by 2, on the long run, you are going to be having 150 minus 150 minus 62.5, that is divide 125 by 2, so the x here will finally be 87.5 meters. That is what we are having there. So this is how you apply your linear equation. You see, when we are talking about this, we're not talking about gravity or at an angle or about a curved path. We only dealing with what? Linear, because we're talking about the object moving in a linear ground. Because where does the train move horizontally? Have you ever seen a train that is climbing up? It is rare, especially in this part of the world. So let's move forward to the next one. Motion under gravity. So move forward, and we're going to deal with what? Motion under gravity. Right? Now, in this case here now, we're talking about an object falling, just like I explained earlier when we are dealing with this. An object that is thrown. When you hear the word object that is thrown, right? Object that is thrown, object that is projected. When you fire an object, when you shoot, when you drop, right? You're dropping, or when an object fall. When you talk about things like this, you're talking about emotion on object that experience this kind of thing are always at the influence of what? Gravity. So what will you do? You know that in our other aspects, in this case, in our other aspect, we talked about V is equals to what? U plus. Now we're not going to, our acceleration here now will be at the influence of what? Gravity. Right? Because you discover that the higher an object, the faster it falls, and the more impact it has. So if I lift my barrel up, I drop it, you are discovering the higher I go, the sound increases, the larger the impact, right? So I'm going to use G as my influence of what? Gravity times time. So from here, it can be plus or minus. Now you'll be wondering, why am I using plus or minus? Now, if the object is opposing gravity, that is, if it's going up, that is its opposite, I throw an object up. Now, since it's opposing gravity, gravity will be pulling it down. I mean, when you're climbing up, you're climbing a staircase, you easily get tired. You feel the pains on your leg because of what? The influence of gravity on you. The gravity is pulling you down. So there's a negative effect on it. So I'm putting minus. So we'll say it will be what? Minus G. And what is this G? G is given as what? 9.81 meter per second squared. That is the G there. Or some textbooks will tell you 10 meter per second squared. But if the object is favoring gravity, let's say if an object is falling from an altitude or from an height, right? It's favoring gravity. If you are coming down from a staircase, you see that you come down faster. It is easier. The impact is large, right? So you put what? Positive G. That's why I explained earlier. The higher I go, the more impact. Why is the impact increasing? It is because of what? It is favoring gravity. Gravity is pulling it down very fast. So that is what? G, positive G. So I'm putting plus or minus. So always be careful whenever you're given a question and you're told the object is moving up. If it is moving up, it's thrown up, no, the gravity there is negative. If it is thrown down, the gravity is positive. Now the next one, we say that X, now what do you notice? If I drop an object down this way, right? This is point A and point B. Now from here to here, we'll call it our S, our distance traveled between A and B, right? Now it's also called H. we call it vertical distance. But if I turn it the other way around, it will become horizontal. So since it's falling from up, the distance from A to B is called h. So if you are talking about linear, you use x. If you're talking about motion under gravity, you use h. So the h is just telling us vertical distance. If you use both of them, if you have to use both of them, always signify that this is what your s is and this is what your h is. So for my own lecture here, I'm going to introduce h to show that what is my vertical distance is equals to what? I'll now put ut plus or minus, instead of at square, I'll put gt square all over 2. So now what do you notice? Every part of my A is being represented by what? By gravity. Now the third one that we have, we say that v square is equals to what? U square plus what? Plus or minus 2gh. And my x here is provided by is represented by what? By h. And the last but not the least, we say that the x here is equal to, instead of using x, I'm going to use h. The h here, I can use capital letter H if I want to, is equals to what? U plus v all over what? 2, then multiply by what? By a time. So I can put it that way. So where g is associated to gravity, h is called the vertical distance. Are we together now? So let's take an example and see how we can implement this. So example 1. We have the example 1 here. Example 2. It says a stone is dropped down a well. That keyword drop, that means it is favoring gravity. If you are dropping, the higher, the faster the stone drop. So since it's dropped down the well and it takes 2 seconds to reach the water surface, so my t here is given to be what? 2 seconds. Let's say this is our data we're trying to write out now. The data. So my t is giving us what? 2 seconds. Now since the stone is dropped, when you hear a stone is dropping this way, is dropping from the top, 3 things you must put into consideration. From where it is starting to where it is ending, we have the initial velocity and the final velocity, and also the young man here called the g. It was always in the influence of gravity. Since it is dropping, it's falling. So u is the initial, because for you to drop something, it means you are holding it, and as you are holding it, means what? It is at what? At rest. So the u is what? Is 0. The g we know is favoring gravity, giving us what? 9.81 meter per second square. Then the v, we don't know how the impact will be. That's why we're calculating it. So the v is what we're calculating. So that's why the question is not telling us here that what? The velocity with which the stone hits the water surface. So the velocity, automatically this velocity here. So we are going to put recall. So if I can input this value here, I can easily say my u is equals to what? 0 meter per second. Then the g is equals to what? 9.81 meter per second square. And the v is what we are calculating for. So let's move forward. So you put recall. What do you think we can use? We're looking for TUGV. We'll look for the equation that have what? TUGV. So let's check and see. From here, we have TUVG. So this one has everything. And we also only have one unknown, which is our V. So I'll use that particular guy. So I'll say recall V is equals to what? U. Now, we're having plus or minus. So how will I know what is plus or minus I'm using? Since it's favoring gravity, I'm going to take the plus. So I have my GT. Because if you look at this, I'm having plus or minus. But because it's favoring gravity, the stone is dropping. So it's going favoring gravity. It's how I'm using positive there. Now from here, what is the V? We are calculating for the V. The U, it is 0. Plus the G is what? 9.81. The T is 2 seconds. So therefore my V will now give me 19.62 meter per second. That is the velocity. Right? Because you multiply this, you have 19.62 plus 0 giving 19.62. Now the next thing we are told to calculate there is look for what after the velocity with which the stone hits its water surface 19.62. Then B says the distance of water surface from the top of what? Of the well shaft. So we're looking for distance. So it is easier. What you just do, let me just do it here. You put recall the S, which will say H, is equals to what? UT plus GT square, everything over what? Over 2. So we're looking for what? The distance. So what kind of distance is that? Vertical distance. This is falling, like I explained earlier. It's falling, so we're talking about vertical distance. So we'll move forward. So the H here now will now be equals to the U we calculated before is 0, as in what we have U is 0. The time T multiplied by what? Multiplied by 2, put in bracket, plus G, we know it is 9.81, positive 9.81 since it's favoring gravity, multiplied by what? 2, but the T here, which is 2, has a square, everything all over what? All over 2. So the H here will now give me 0 times 2 is 0, plus now 19.62. Why? 2 square is 4, 2 and 4 is 2, 2 times 9.8 will give you 19.62. So definitely my H is given as what? 19.62 meters. That is the vertical distance, or the distance traveled. And distance is measured in what? In meters. So this is how you apply questions on motion under gravity. Now we'll now go into that of angular motion, motion about a curved path. So go under angular motion. But before we go to the next aspect, I would like you to look at this question very well. The next question: a projectile is fired vertically upward. Pause the video and see if you can solve that question. It says a projectile is fired vertically upward and reach a height of 78.4 meters. Now, since the object is fired vertically upward, that means one thing you need to notice is that what? It is opposing gravity. So our G is what? Minus 9.81. Then the height, vertical height is 78.4 meters. And since it's going upward, we are moving upward, right? Our initial is U, our final is V. Starting point is always U, ending point is what? V. So just try that particular questions. We'll meet in our next video. Now looking at angular motion here, we're talking about motion about a curved path, motion about a fixed point. An example of motion about a fixed point, we're talking about rotational motion, we're talking about circular motion, we're talking about simple harmonic motion. Now, the displacement of the object is always along a curved path. For instance, if I have a hill this way and an object is moving along this A and B. Now, there's a center here, right? This is the difference between the center and this point here. That means if you are going along a circular path this way, right? So if you are moving from A to B, the angle between them is called theta. I will call them angular displacement. So then the velocity v is given as angular velocity. So instead of me using v is equals to ut, my v here will be final angular velocity. I can call it 1, w1, right? I call it omega, is equals to initial angular velocity, which is taking our u, plus our acceleration here is giving us what? Alpha. Call it angular acceleration, times what? Times t. So we call our alpha angular acceleration. Now the next one, instead of using our x is still there. X is for linear distance or vertical distance, but if we are moving here, our x representing angular displacement, so we are going to use the word theta, because from here to here is displacement and the angle between them is what? Theta. So our s is for theta. Then u, we know it is initial angular velocity times time plus what? At, which is angular acceleration, times what? T square all over what? 2. That's the next one. Then the next guy again, we say v square, we use final angular velocity is equals to u square initial angular velocity plus we have 2. A is given as alpha, then S is given as what? Theta. Then the last but not the least, so including this also represent the theta angular displacement is equals to initial angular momentum, angular velocity plus final angular velocity over 2 times t. So we know what all this parameter is, right? Now one thing you need to understand here is that this is final, this is initial plus angular acceleration and time, and so on and so forth. So if you notice what we did this morning, we have all been playing with the same thing. From the first guy, we said v is equals to u. If you compare them to the second guy here, we change some things to g. They are all the same, but until we get to this point here. Now let's apply this into our equation here. Look at this question here now. It says a disc slows down from what? 85. So it's slowing down. So that means our data here, the initial angular velocity is what? 85 rad. Now angular velocity is measured in rad per second, while velocity is measured in what? Meter per second. Now tau, so that will be the final, is moving from this to this, and that is what? 25 rad per second in 4 seconds. The t is given as what? 4 seconds, right? What is the average angular acceleration? So we're looking for what? For acceleration. Don't forget one thing, that it is what? Slowing down. That means it is what? Decelerating. Now we're looking for initial, final, and time, then acceleration. That means it is in what? The first equation. Initial velocity, final velocity, acceleration, and time. So we are going to put it this way. We will say that what? Recall final velocity, angular velocity is equals to what? Initial angular velocity plus what? Acceleration times time. The final here is given as what? 25. The initial is given as what? 85 plus acceleration, angular acceleration times what? Time, 4. So when this 85 come here to be 25 minus what? 85. Changing the sign from when it's crossing the equal sign, equals to what? 4 alpha. So 85 minus 25, that will give us 60. That was 60 minus 60 equals to what? 4 alpha. Dividing both sides by 4 to be minus 60 all over 4 is equals to what? Alpha. and alpha is equals to what? 15 rad per what? Second square. Angular acceleration is given in rad per second square, but there's a negative there. So the negative implying that what? It is what? Decelerating. Since it's moving from highest to lowest, so it is what? Decelerating. This is how you apply some of this formula. In my next video, I'm going to solve miscellaneous problems involving motion, both in angular, linear, and motion due to gravity. And there's something I didn't introduce to you. Still, there's another one that is called motion under motion, that is motion under gravity. Right, we've talked about that one. And sometimes the motion under gravity can be projected at an angle, right, in terms of projectiles. So when you project at an angle, you're talking about what? Projectiles now. So now next video we'll talk more about this. If this video was helpful in one way or the other, please don't forget to click on the subscribe button and like the videos. Thanks for watching.